Hello, and welcome to the Recitation 0 section of AWS. I'm going to walk you through crucial steps to use this particular cloud computing service, including how to launch an instance successfully that is capable of running deep learning models, how to copy files to and from your instance, and how to run Jupyter notebooks from the instance. So let's get started. So the first thing that you want to do is to register for an AWS account. I trust that you all know how to do that. I'm not going to walk you through the detailed steps on that front. But when you're done registering for an account, this is what it's going to look like. So this is the AWS homepage. And the first thing you want to do if this is a new account is you want to raise what's called the service quotas or EC2 instance limits of your account, because by default, your account is not permitted to run advanced machines, which you will probably need in order to run deep learning models. So let's first make sure that we are in the correct region, because these instance limits vary region by region. If you raise the limits in one region, it does not raise the limits in other regions. So you better stick to one region throughout your work on AWS. And I have chosen this particular region of Northern Virginia. You can choose Ohio as well. But of course, geographically, the farther away it is from your actual geographic location, the higher the latency is going to be when you connect to your instance. So for me, I'll stick to the Northern Virginia region. And so in order to see what our service limits are, let's type service quotas in the search bar, and let's go right here. And so this is actually a new sort of user interface that if you used AWS in the past, it keeps changing. But the way to see our particular quotas that we are interested in is to type EC2 in this search bar and click on this thing called Amazon Elastic Compute Cloud bracket EC2. So let's view quotas. And here on quota name, we want to type instance. So this actually brings only those quotas that are related to the specific instances that we want to run in this panel. So in here, I need to explain what is meant by sort of on-demand instances and what is meant by spot instances. So because you can see here that a couple of limits are titled running on-demand X instances, and other limits are titled running X spot instances. So the way that AWS works is that when you want to order an instance, which is what their name is for a machine, you will get one on the on-demand price. And on-demand here means that you will have it basically as soon as you want it. And there's no compromise. As long as you want it, it's going to be there for you. So it's running on your demand. So it's called an on-demand instance. But from AWS perspective, a lot of their machines are not getting used all the time. So what they do is if they have an idle machine, there's a chance they might issue that assign that machine to you if you are willing to pay for the spot instance price for that. And the spot pricing is usually a lot lower than the on-demand pricing. So the spot instances is another name for AWS's idle instances, and you can get that with a much lower price. But the caveat is that when somebody pays for that same machine with an on-demand price, AWS can retrieve that machine from you at any time. So basically, your connection to that machine is not considered as stable as the on-demand machine. If you have a spot machine, you have it at a very low price, but AWS can get it back at any moment. So you cannot use a spot machine or a spot instance to run important jobs. And there are a couple of numbers here, but the only thing you need to know is actually, let's say you want to run on-demand instances, and let's say you want to run P instances, right? So what do all these instances names mean? There are a couple of, you can Google it. There are a lot of resources online that explains what kind of detailed configurations there are in these machines. But for now, let's just say we want to run on-demand P instances. And I particularly recommend either P instances or G instances for deep learning purposes. So right now here, you can see that I have a limit of 8. But if you have a new account, chances are you're going to have a limit of 0. So if you have 0 here, you need to click on this button. This is request increase at account level. So here, um, if you have 0 here, type 8, or even higher. But I think that if you type in a new increase that it's too large, then chances are they're gonna reject your application, or else give to something in between. So let's just stay with 8 here. And you want to click on this button that says request. I'm not gonna do it here, but if you click on request, it's gonna create a support case that they're gonna review case by case. And it's going to take, I think, a couple of days before they can get back to you. So you want to do that ASAP before you actually need to start using AWS. So in here, type a number that you'd like, most probably 8, click on request. And after the support case is open, you can type additional explanations, like, I'm a student at CMU and I need to use AWS for this purpose, specifically for this course I'm taking. And you can append the course website, etc. for their internal purposes. So that is how you need to request a limit increase for AWS. And as to what these numbers actually mean, like what does 8 actually mean? It actually means number of virtual CPUs that AWS can handle to register on your account. But the specifics you can always look up. For the purpose of this presentation, just know that you need to request this account limit increase. All right, so once we're done requesting the limit increase, let's go back to the homepage of AWS. And let's go to our notebook. So this notebook is unlike it is appended, I think, in the same Piazza post that you got to this video. But the thing is, this notebook is not like one of the other notebooks where it has Python code that you can run. AWS is just shell commands. So I've listed all the commands here. So the first step we already took, we requested a limit increase, and the next thing we want to do is to launch an instance. So all of these are not actually Python commands, but bash commands. So you can copy them to your actual terminal to run those. So all right, let's go back to the console, and let's go to EC2 by typing this on the search bar, and there we go. All right, so we need to click on this button that says launch an instance. Let's launch an instance. So the name can be whatever. I'll just say ideal rec0 test. All right. So the machine image that we want to launch our machine on is something that is analogous to an operating system. It is more than an operating system, but it basically is the configuration of the machine, not on the hardware, but on the software. Basically, what kind of operating system, what kind of libraries, what kind of software that can be pre-installed with the system. So let's type deep learning here. And let's click on this one. So and you see that when you select particular machine images, it's going to say what kind of EC2 instances it supports. So this one says it supports P4 and P5. So yeah, whatever. Let's just try with the first one here. All right. Okay. So in here, let's actually select a class machine type. So let's see if we have the P2 over here. So I'm gonna launch the P2.x large. It's gonna come with 4 vCPUs, which is within my limit of 8. But just so you know, these machine instance types, some of them you can launch, some of them you cannot, and that depends on the number of their vCPU and the specific account limit that you have in your account and in this region. All right, so let's select this instance type. And as for the key pair, it is actually required to have this in order to be able to log in your AWS instance later on. So, I mean, I already have these key pairs, but let's generate a new key pair just for the demonstration purpose. So, as with usual, I'm going to say IDL rec0 test. in here, and I'm gonna select the .pem key type. So let's create key pair. All right. So as you can see on this Chrome menu, it says that I have downloaded this file that's called this. So what this means is that I'm gonna have to use this key to connect to my machine later when I need to. All right. So so do not delete this key. If you delete it, there's no way to get it back. All right. So for the network settings, I'm going to create a security group, and I'm going to allow SSH traffic from anywhere. You can also toggle these on. These are not too important, but for demonstration purpose, I'm going to stay with the simplest setting. And for the storage, we're not really doing anything here, but if you are running an actual model training job, then you need to specify how much storage you need for your data and your other sort of files you want to store in your operating system. All right, so let's launch instance. Oh, and final thing, as I mentioned, there is a way to summon what's called spot instances versus on-demand instances. If you want a spot instance, then there's actually a menu to do that here. All right. So if you toggle this on, that says request spot instances, this is going to actually give you a spot instance, but we're not going to do that here. All right, let's launch instance. All right, the instance is successfully launched. So let's click on this button that says instances. All right. So as you can see, I have this instance that says pending, and pending this just means it's just starting. So let's wait for it to finally start. Let's click on this instance ID. All right, so now it says running. And how do we connect to this machine? So the way to connect to it is to click on this connect button. And as you can see, there are a couple of options how you can connect to the machine. And the simplest and dumbest way is to use what's called EC2 Instance Connect, and that's actually just going to open a web console if you click on this button. It's basically going to look like a terminal in a browser, which has a high latency, so I do not recommend this. Instead, what you really want to do is to use an SSH client. So um, this is going to use the SSH command that I have specified in the notebook here. So the overall format of this command is to type SSH space -I space your key location. So basically -I is the option to specify a key for connecting to another machine. So after supplying this option, you want to type another space and type your actual machine address. And the format for the address is username at hostname. So in here, you can see that they already typed this out for you. You have, SSH-I, and the specific key that we created earlier, as well as your username, which just turns out to be Ubuntu at this particular host name that comes with AWS. So let's copy this entire command, but keep in mind that this key file needs to be in wherever your working directory is. If it's not, then you need to supply the actual location of this file that we just downloaded. In my case, it's actually going to be in the downloads folder. So let's copy this, and let's go to our terminal over here. Please bear with me 1 second. All right, let's go to terminal. All right, so let's paste this command, but instead of this key file, let's actually say downloads / this file, because it is in downloads, right? So let's connect. And when the terminal prompts us, let's say yes. So so the thing specifically with AWS or a lot of cloud computing services is that they actually need you to protect your key file so that other users on your operating system cannot use it. So what we're going to do is we're going to say chmod 700 downloads, and then we want to say our key file. So basically what this means is this is going to give the owner user all the accesses for this file, but other user groups, none of the accesses. So let's do that and let's connect again. All right. So as you can see, we are now in the AWS instance. And you can ls here. There is a couple of seconds of latency between when you type the command when it actually appears on the screen because it is actually a screen far away. So, there's vim, there's cat, there's a lot of basically this is a Linux operating system with all the usual defaults. So, all right. So we have done our second step, which is to connect to a Linux system on the AWS machine. So let's focus here on how we can actually transfer files to and from our machine, right? So you can take a look at my notebook, which is pretty simple. Let's actually go back to the notebook over here. So, so here, the notebook actually says sending a file to the instance is doable via this command. So let's do that. And the way to do that is to use this command, but switch the key into the actual location of the key file that we downloaded from AWS. The local path would be the path that the file lives on our local machine. And as usual, as in the last step, the user add hostname is the same. And then after that, we're going to append a colon and the remote path that we want the thing to live on in the actual server. So let's try that. Let's go back to the terminal over here. All right. So since this is already our machine, let's run pwd just to learn where we are. We're in /home/ubuntu. So let's open another terminal in the local machine. And so I have a couple of dummy files over here. Let's for example, let's say we want to look at calcfib, right? So as you can see, it is a file, 42 lines. So let's transfer this file up to our AWS server. So the way to do that is to first copy this command. All right. So the key file, of course, is going to be downloads space our file, right? And the local path would be the file that I want to send relative to where I am located right now. So this is just going to be calc.py. And the user is just Ubuntu, and the host name is going to be the same as what we did before when connecting to the machine. So I'm just actually going to copy it over from the AWS website, which is this. All right. And now we want to fill in the remote path. So the remote path is the path on the AWS machine that we want the transferred file to live on. So if you look at the machine, we want to actually just do /home/Ubuntu because that's where we are now. So we want to say /home/Ubuntu and run the command. As you can see, the file is being sent 100%. So let's go back to the AWS instance and let's run ls. And there we are. Our calcfib.py is right here. It hasn't been here before, but it's right here because we just sent it over. So let's cat this file. You might have noticed that I used a command called bat on my local machine. That's because bat is a little more fancy and colorful, but cat is the same thing. So let's look at the file, and surely enough, this is the same file. All right, so let's download a file from the AWS instance. And the way to do that is exactly the same as our last command, except for the switch between the source destination and the target destination. So let's download, for example, the Linux packages list, right? Let's first um, take a look at what it says. So it's just listing a long list of packages that is existent, most probably on our machine over here. So let's just go back to our local machine, and we still want to run scp space -i space the key file. But after that, we will specify the source file first, right? Because in the last run, we specified the source file, which is calcfib, and we specified after that we specified the target destination, which is the remote address. So now the source file is in the remote address, so we're going to specify that first. And as for the specific file, we want to say /home/ubuntu/linux packages list. So Linux packages list. And after that, we want to say, where do we want that file on the local machine? And the way to specify the current working directory is just a dot. So we just write a dot. All right. So we run the command, and boom, there it is. So apparently the file is downloaded to our local instance. And sure enough, it is here. And let's bat it. Sure enough, with 12,000 lines, that is the file that we looked at just now on the machine. So this is how you would transfer files to and from the your AWS instance. And it doesn't matter whether you transfer code or data, except for if you're actually transferring data, it might be easier to first zip the file or zip the big folder that you have before sending it to the server, because transferring is a high cost operation, and you can always zip it locally, transfer it to the instance, and then unzip that remotely on the instance, which is going to be faster. But essentially, this is how you transfer anything to and from the server. And the other way to do that is to use a Git repository, which I'm sure that you know or have learned how to use with this Recitation 0. So you can commit code to a Git repository, and on the server, you need to supply or basically clone your own Git repository, and your code will be there. So this is how you transfer files to and from the AWS instance. All right, so after we're done with this, we need to go back to our notebook. Let's go back to our notebook here. And apparently, a lot of people like to run Jupyter notebooks. I personally don't do that quite as often, especially since Colab tends to give you a interface that is more convenient for your run notebooks. But if you have a AWS instance that comes with a powerful GPU and you would like to skip having to fight with Colab all the time for its various issues, for example, kicking you offline, etc., it might be desirable to run a notebook on AWS. And the way to do that is to first run this command on the server. So this is actually going to start the Jupyter notebook on your AWS instance. The problem is that you will not be able to see it on your browser, because locally, the way to run Jupyter notebook locally is also to start it on the terminal and then use a browser to view that, right? But the problem is you don't have the graphical interface on your remote instance, so you cannot use a browser to browse that notebook. So the way to do that is to, after starting the notebook on the remote instance, tunnel your local port to a specific port on the remote instance, so that if you know what port your Jupyter notebook is running on the remote instance, you can use that specific local port designated to be tunneled to that remote port to view whatever's happening on the remote port. So I'll walk you through it right now. So let's first run this command. Let's go back to the terminal. All right, so let's see. So let's run this remotely. This is our remote instance. Let's run this. We have to install Jupyter. All right, sure enough. Let's just say sudo apt sudo snap install Jupyter. All right, looks like Jupyter is successfully installed. Let's run that command one more time. All right. So it looks like our Jupyter Notebooks process is up and running. So as with detailed in the notebook, we will take note of the token that is specified in this process. And specifically, we need to take a look at this sort of what it looks like a website address over here. It is not an actual website because it's on the local host, but do know that take a note that the port on the remote machine is 8888, and the token starting with AE92 is this string over here. So we need to be able to retrieve the token if we want to run it or view the notebook on the local end. So the next step would be locally to connect to the specified server port. And the way to do that is to switch back to our local terminal and run this command. So basically SSH dash capital L and use a different port than 8888, for example, 8889. And the reason why we want to use a different port is because by default, Jupyter Notebook uses 8888. So if you want to run another Jupyter Notebook on the local machine simultaneously, you cannot use that same port because after we run this command, the local port of 8889 is going to be directed to mirror whatever happens at the remote port of 8888. And had we used the local port of also the 8888, then that will interfere with whatever Jupyter Notebook process that we would have been running. So in order for Jupyter Notebook to stay with its defaults, which is gonna be more convenient for everyone, use a different port to be forwarded to the remote port access. So let's forward the local port of 8889 to the remote process to the remote location. And the remote location is confusingly named local host. Yes, and that is because the local host is the local remote host. So basically, that is the local host on the remote machine. So even if it says local host, this actually means that we are forwarding 8889 to the sort of local host 8888 on this machine that we specify after that. So the machine is called remote user at remote host. And as usual, these are listed on the AWS instances page. So let's copy that right over here. So, all right. Might have messed things up here. All right. So let's create this SSH tunnel. Oh, and I forgot we need to specify the key over here. So let's say -i downloads the key. All right, let's do that again. All right. So we have created an SSH tunnel. So now on the local browser, we need to open localhost colon 8889. So here, you can see that this is actually showing a Jupyter Notebook page. And we have not started a Jupyter Notebook process on the local machine. And the reason is because the localhost colon 8889 is now the same as remote localhost 8888, right? So now it asks us for a password or token. So we need to get back to our token over here and copy this. and paste this in. And now we will type login. All right. So let's actually not save that particular token this time. So you can know that this is actually the Jupyter Notebook on the remote machine because of all these files, right? You recognize this is not on the local machine. This is on the remote machine. And we have successfully started a Jupyter Notebook process on an AWS server. And if you want to start a new notebook, just click on new notebook. This is the same old deal that you have with Jupyter Notebooks. And I've just demonstrated how you can run the same process, not on the local machine, but on the AWS machine, being able to view it from the local computer. All right. So that is actually all I want to demonstrate with this particular Recitation Zero section on AWS. I hope that you have learned how to create an AWS account that is capable of running advanced instances by raising your service limits, how to launch an instance, specifically copy files to and from your instance, and importantly, how to run a Jupyter Notebook on your AWS instance. If there is any question, post on Piazza or come to my office hour or any other office hours and let us know. Good luck.